Okay, good. All right, so this APK was designed to get you thinking about how you might represent a force visually. Right? How are we going to draw forces when we put them on the paper, when we talk about them in detail? How are we going to draw them? So that's one of our big questions. We're going to write, so before we start, title the top of your piece of loose leaf force diagrams. Okay, so make sure the top of your loose leaf has force diagrams. And then we're going to write two big questions. Big questions. One, how can we visually represent forces acting on an object? Two, if there are forces always acting on objects, how do they remain motionless or at a constant velocity? Okay. How can we visually represent forces acting on an object? And if there are forces always acting on objects, how do they remain motionless or at a constant velocity? Cool. All right. So let's talk about how we're going to visually, well, let's talk about question 2 first. If there are forces always acting on objects, how do they remain motionless or at a constant velocity? So our example up here is going to be this anvil. It's swinging a little bit, but let's consider that it's motionless. Do you guys think there's forces acting on it?
Yes.
Yeah. There are forces acting on it. How is it able to stay still? There's a key word in our last kind of discussion on what we know, and what we even talked about it yesterday, that is very important to understand. In certain cases, when forces are blank, we have things that sit still or travel at constant velocities. Everyone remember what needs to be balanced? Thank you, Elizabeth. If forces are balanced, they result in motionless, something that's motionless, or constant velocity, no changing in the velocity. So let's actually write that down. So balanced forces result in a motionless object or an object with constant velocity. Okay? So keywords: balanced forces, motionless, or constant velocity. So two situations. And those come from Newton's first law, that an object will be motionless unless an unbalanced force is acting on it. Objects that are in constant velocity will remain in constant velocity unless an unbalanced force interacts with it. Okay, so let's draw a force diagram for this anvil. So, drawing force diagrams. Alright, I'm going to try to go through this real quick and then give you guys a chance to draw your own force diagram. So stay with me for about 5 or 6 minutes, and then you guys are going to get to do it yourself. So first we have to define what we are drawing our force diagram on. So in this situation, there's a whole lot going on. We have an anvil, we have a rope, we have the ceiling, we have the school, we have the earth, we have this building, right? We need to simplify things to what we want to study. We're going to choose a point or an object that we're going to say this is what we're drawing our force diagram on. So in this case, let's choose the anvil as our object we're going to draw a force diagram. So your first thing that you need to do is choose the object you're drawing a force diagram for. That's force diagram. Okay? Choose an object. Then the next thing you're going to do, since you think this would be an easy thing to draw a picture of, like this crazy looking anvil, or what do you think we could do when we're drawing a picture? Can we simplify it?
Yeah.
What do you want to simplify it to? Can we simplify this into something very small and easy to draw, just like a
circle?
Yeah, a little dot, right?
Yeah.
Simplify object to a dot. Alright, so let's draw a dot for this anvil. Here's our dot. So this is the anvil. Okay, there's our dot. An important note, I'm going to write this and then we're going to talk about one of the forces that are acting on it. Forces, the force vector, the force arrow we're going to draw, point in the direction that it would cause the object to move. Okay, so force, I'm going to write that, force vectors will point in the direction they would cause the object to move. Alright, so what's one force that is acting on this anvil? Elizabeth, you said you think there's forces acting on it. What's one force you think that's acting on it? Gravity. Gravity wants to do something to this anvil. Which way would it be pointing? Down. Right? So we're going to draw that arrow. We're going to start it at the dot, and we're going to draw an arrow straight down like this. Force vectors will point in the direction they would cause the object to move. Gravity would pull it down. We draw an arrow going down. Okay? When we name a vector, this is the method that we're going to use. And you guys are going to put this into action in a few minutes here. We're going to say big F for force. And in little parentheses, you're going to write the type of force, comma. There's a little rhyme to help you remember. On feeler by dealer. So what's feeling the force and what's dealing the force? So, Zinzi, can you help us out?
Yeah.
Well, Elizabeth already said this is a force. What's causing the force, Elizabeth? Gravity. So the type of force is a gravity force. We're just going to call it a gravity force. Zinzi, what's the feeler?
The dot.
Okay, what is the dot representing?
The
anvil. Yeah. So we'll say on anvil. On anvil.
By viewer.
By, what's causing gravity?
That was a deep question.
What's causing gravity?
The earth.
The earth. Perfect. So on anvil by earth. Great. Force of gravity on anvil by earth. All right. This is our force diagram. Done? Balanced forces result in motionless object. So, is this a balanced force diagram? Doesn't look too balanced. There's one big vector pointed down. If it's motionless, we will expect that there are balanced forces. So there's got to be another force somewhere. I'm looking over here. What's our other force that might be acting on this anvil? Here's my hint. Don't overthink it. What do you think? Not there. What's causing a force? Gravity's pulling it down, and we need something to balance that out if it's motionless. There's something already acting on it. What's holding it? The rope. Okay, the rope. Do we agree the rope might be applying a force? Okay, so which direction is it applying a force, do you think? Sorry, Elizabeth, Lily, Tristine. I'm going to go with Tristine. Which way do you think it's applying the force? Tristine. We need balance. Which way do you think it's applying a force? You're going to help me out on this one. I need you. Gravity's pulling it down. Where do you think the string is applying a force? What do you think? Give it a guess. Down? Do you think the string's pulling it down? Think about that. Which way is it pulling the anvil? Up. Yeah. The string's applying a force that's pulling up. Okay? So let's draw our vector pointed in the direction that we'd expect it to go. And let's name this force. Force of, let's call it just a pull for now. Force pull, that's what's it on. Julia, what's it on? What's the feeler? What's the feeler? What's feeling the force of that pull? The anvil, yeah. By Lily, what's applying the force? Not gravity, you said it already.
Oh.
The rope. Yeah, by the rope. By the rope. All right, good. We're getting there. We're struggling through it. It's good. All right, so we have these force of gravity on an anvil by the earth pulling it down. We have the force of a pull on the anvil by the rope keeping it up. If we have balance, we would expect to see a motionless object. Look at this anvil's not going anywhere. It's just sitting still. It's suspended by two balanced forces. So if these forces are balanced, we would expect that the size of this one, same, equal, greater. What would happen if it was greater?
Same.
Why same?
Because it's staying in sun.
Okay, right. They're balanced. So one way we can show that is with equality signs. You may remember this from geometry. Two little equal signs on there show that those are equal forces. Great. That's all I've got. You guys now have, this is station 7. There are 6 other stations in the room that you need to show on your loose leaf. I've written on here, station 1, anvil's the object we're looking at. You're going to draw a force diagram for the anvil. There's 6 more stations. One's going to be up on the screen, where you need to draw your best force diagram that you can come up with, using this naming system and equality marks on your diagram, okay? The one thing I'm not too worried about is the type of force. We haven't really talked about how to name forces yet. I want you to give it the best name that you can come up with. But really try to get this part right. What's it acting on, and what's applying that force, okay? Type of force, on feeler, by dealer. Got it? Okay, so you guys have about 20 minutes. Before you leave, you need to do 3 questions on Google Classroom. So 15 minutes maybe to do your force diagrams, and then leave 5 minutes to answer those questions on Google Classroom. All right? So spread out. You can work together if you need some help, but you can do it individually if you want to. 6 force diagrams for the stations in the classroom. Great.